Section B, multiple choice. At question 11, which of the following mechanisms does not occur in the reactions of bromethane? This is bromethane. What we need to think about is the carbon is delta plus and the bromine is delta minus. Now this is a halogenoalkane. You will know some of these reactions. The first reaction should be aware of, probably the easiest one of the three, is the nucleophilic substitution reaction. Hydroxides, ammonia, cyanide will attack the delta plus carbon and react. So nucleophiles attack here. Radical substitution, reactions of alkanes, UV light. This will also take place with a halogenoalkane, removing a hydrogen and adding on a halogen. Finally, elimination reaction, attacking a hydrogen from a neighbouring the CBr, so an H from here, here, or here, forming elimination reaction. Electrophilic addition will not occur. Electrophiles will not be attracted to the CBr molecule, part of the molecule, so no reaction. That's with alkenes. Question 12. Empirical formula, simplest whole number ratio. So I've drawn out displayed. It's easy to work out displayed. Then count the H's, count the oxygens, and you get to C5H10. Question 13. We're looking at total number of structural isomers of molecular formula C2HBrClF3. Draw out the structure, any structure that's number 1. Look for rearrangements. I've used skeletal here and try to think about different ways of drawing it. So switching out a number of F's on this side, F what side, CLBr. Look at that, those three examples and see how they were worked out. The answer is 4. Question 14. Which contains most chloride ions? Well, first of all, we need to write down the formulae of those compounds. That's important. There's 3 chloride ions per aluminium chloride species, 2 for calcium chloride, 1 for HCl and sodium chloride. Work out N equals C times V, moles equals volume times concentration. That gives us the number of moles which dissolved. Then you multiply by the number of moles calculated here times by the number of chlorides per species, which times by 3 for aluminium chloride, 2 for calcium chloride because there's a 2 there, and then times by 1 because of the 1s in that case. That gives us the total number of moles, therefore calculates the total number of ions. Functional group isomers, we're looking for a same structural formula, same molecular formula, different structural formula with a change in functional groups. So here in A, this is the correct answer. Alkene has changed to alkane. It's got the same number of carbons, 6 and 6. That's the right answer. These are alcohols, but the same structural isomers, but positional isomers. So this is 3 position, 2 position. That doesn't count. It's not a functional group isomer. It has the same functional groups. Here we've gone from 5 to 4 carbons. They're not isomers. They have different molecular formulae. And then here, this is a positional isomer. 16. Quite a lot of work for 1 mark. What we need to do here is to work out the mass. We've got the equation, hydrogenation of ethine to make ethane. It's a 65% yield. That we'll take into account in a minute. What is the mass in grams of ethane that can be produced from 16.20 grams of hydrogen? Work out the moles of hydrogen. We're going to use a ratio. Work out moles. It's a 2 to 1 ratio. Divide by 2. Therefore, work out the moles of ethane. 4.05 moles. Work out the mass of ethane that could be produced. Moles times molar mass gives us mass. Times by 60%, so 0.6 times by 1.5 gives us 78.98. We've got the answer, which is B. 17. Which molecule does not have a permanent dipole? What's CF4? All the other molecules have got a permanent dipole. You can see, for example, here that this end of the molecule would be more negative, pulling electron density away from the H. Here, pulling away from the H down this region. Here we're pulling up towards the chloride here, so that would have a polar dipole. Here, an uneven distribution of charge is a way of describing a dipole. Here, equal pull all the way around the molecule, therefore no permanent dipole. Question 18. This is the incorrect arrow here. You look in your notes, you'll find this reaction mechanism. The arrow should go from the bond to the N, reforming the lone pair on the nitrogen. So base ammonia takes the H. This H does not get the lone pair. The lone pair goes back to the N, removing that plus charge. So it's a lone pair on that molecule there. 19. Got to spot the Z. Z of the Z-retinal molecule, and what we're looking at is to see which. We're looking at substituents. Let's look here. This is the answer around here. It's C. What we look for the heavy substituents. So A and C are the heaviest substituents around this double bond, whereas that's a methyl group only. That's just an H. So A compared to B, A is heavier. C is heavier than the A. The C substituent here is heavier than the H. They're on the same side, therefore Z. Question 20, reaction between magnesium and sulfuric acid. What happens if we have the same temperature but the concentration of sulfuric acid has been halved? So if we're halving the concentration, we are going to slow the rate of the start. Now, because magnesium is in excess, this moles of sulfuric acid will affect the final position of how much H2 is collected. Therefore, it halves the total volume of hydrogen collected. Question 21, just find yttrium, it's in the D block. Question 22, it is, we're looking at the trend in atomic radius across period 3 in the periodic table, and the correct answer is radius decreases because nuclear charge increases. There is no change in shielding, or very little, maybe a little between S and P, but not much. Again, that's incorrect as well. This one is incorrect. The number of protons increases the pull on the electrons, which reduces the radius. Question 23. QSO4. Well, if it's QSO4, first of all, SO4 is a 2- charge. Therefore, this compound is going to be Q2+. To get Q2+, you're going to have a 3s2 as a neutral atom. It's going to lose 2 electrons, and therefore it's going to be 3s0. That's going to give a 2+ charge. 24. We are looking at a reaction that does take place, and the only one that does take place is A. This is a halogen-halide displacement reaction. Chlorine is a strong oxidizing agent. It's going to remove the electrons from the iodide, leaving us with sodium chloride and iodine. This one doesn't take place. Bromine cannot oxidize chloride to chlorine. It's not a strong enough reducing agent. This one just doesn't take place. Sodium chloride dissolves in water but doesn't form hydroxide and HCl. And then this one here, we are looking at, well, chloride is not a strong enough reducing agent to reduce sulfur in H2SO4 to SO2. It does not carry out that step. Bromide and iodide does, that's part of your specification, but not Cl. 25. We have, just to work out some oxidation states, what you do, I'd annotate around each molecule. -3 + 1 times 3 for the 3 H's makes +3 H's, so that's neutral, that's correct. Oxygen is -2, it's more electronegative. 2 lots of +1s, so that makes +2 for those two, that's neutral. Start with hydrogen +1, likely to be +1, except with metal hydrides, like lithium hydride, where it's -1. Got 2 times -2s, oxygen is mainly -2, there's 2 of them, so that makes -4. So +3, +1, -4, neutral overall. So those are the correct oxidation states for nitrogen in each case. 26, again a tough question, more appropriate perhaps years gone by in the upper 6th. However, quite possible for you to see this. What we need to do, work out the volume of barium hydroxide required to neutralise this volume and the concentration of HCl. First, let's work out the moles of HCl. So that's that row there. Volume times concentration. What you need to take note of here is barium hydroxide will dissociate to form two hydroxides. So its concentration of hydroxide ions compared to barium hydroxide is actually double. So it's 0.2 becomes 0.4 because of dissociation of the barium hydroxide into solution. To work out volume of barium hydroxide required, moles divided by concentration. Moles is here. No, that's incorrect. Moles is here, 0.003 divided by 0.400 times by 1000 gives us 7.50 cubic centimeters. Question 27, atom economy. The way you work out atom economy is you take the total sum of the MRs of the desired product divided by the moles of the total MR of all products. Let's look at an example. Now let's look at the one that has the greatest atom economy. So it's 3 H2s there. They have a total MR of 6. 3 times 2, 2 being the relative molecular mass of H2, is a 6. Divided by 6, which is the H2 again, 3H2, divided by 12, which is the carbon, divided by 16, which is the oxygen, then times by 100. That gives us an atom economy of 17.6. Let's just look at one more example. So the desired product again is H2, and this one here, that's only 1 mole, so it's 2, divided by, well, all products, so 2 again, then 12, 2 oxygens makes 32. So you need to take into account the number in front of, this is unusual really for this sort of calculation, but this is atom economy, it's not a moles calculation as such. So that's why we take into account the number in front, and that's important here and here. Which species is the strongest, best oxidizing agent in 28? Chlorine. So chlorine is a small molecule, smaller molecule than Br2, so it's going to attract electrons more readily. These two here are more likely to be reducing agents because they're negatively charged, lose electrons, rather than oxidizing agents and gain more electrons. 29. So 41K plus, talk about its number of electrons, protons and neutrons, calculate those. Well, take it step by step. It's got 19 protons. It's got 1 less electron because it's a plus charge, so 19 minus 1 equals 18. And 22 neutrons because it's 41, take 19, gives 22. So that is C. 30. Another quite lengthy question. We are looking here at calculating the original mass of zinc used to make some crystals. So, first of all, let's work out the moles of crystals formed by the student. So, mass divided by molar mass is how I calculate molar mass. Don't forget to include 7 times 18 for the water of crystallization. It's a 70% yield. So what I've done here is I've taken the moles from this first step and scaled it up. So you scale it up to see, well, how much would it be if it were 100% yield? So that gives the number of moles there, times by 65.4, which is the molar mass of zinc, gives us 13.3 grams. Question 31, which of these is a redox reaction? Study all stereo reactions and look for a change in oxidation state. Here we see magnesium changing from 0 to +2, sulfur from 0 to -2. That is the obvious choice, 31D. The others, you can see that they're look for a change. High oxidation states are most likely to change. So silicon is still +4, unchanged. Sulfur +6 is unlikely to be a redox reaction if the high oxidation states are the same. Oxidation state elements have the same oxidation state before and after. Question 32, we are looking at empirical formulae calculations. You need to work out, again it's a lengthy question, you need to work out the data for N, C, H and O, so the mass of each of the elements. So you immediately can put 0.473 in there. 33.8% is carbon, so 33.8% of 2.40 is that mass there. 1.41% of 2.4 is this mass, and then do a subtraction. 2.4 take N carbon H gives you 1.08820. Mass moles ratio table, so mass moles, so divide by relative atomic mass of each of the elements gives you the moles of oxygen. Divide by smallest number, of the smallest number from here scales up to 1, 2, 1, 2, and then the answer therefore is C. And the final question, question number 33. What's the number of atoms in 0.01 moles of ammonia? Well, there are 4 atoms in 1 molecule of ammonia. Therefore, if we have 0.01 moles of ammonia, that will be 4 times by the number of moles of ammonia molecules times by Avogadro's constant, which is the number of atoms in 1 mole of substance, and carry out that calculation leading us to 2.41 times 10 to the 22.